Assalamualaikum and hi everyone. Okay, so this is video 4 for chemical bonding. In the previous video, we have been introduced to covalent bonding, the first part. Okay, the first part of covalent bonding and also the coordinate bonds. Let's continue with the subtopic of in the covalent bonding. Oh yes, in the previous video, I have mentioned about triple bond is stronger than double bond. Okay, triple bond is stronger than double bond is stronger than single bond. All right, so also triple bond is much shorter than double is shorter than single bond. Okay, so basically, why is that? Okay, so the answer is the triple and double bonds have more electrons. Okay, so in this case, triple gets more electrons because the sharing of 6 electrons. So they exert a stronger attractive force on the nucleus. Stronger attractive force on the nucleus. So it makes the bonds become stronger because of more electrons. Okay, in the case of shorter, because when we get more electrons, because the electrons pulls the atoms closer. Okay, so they pulls the atoms closer together. That is why the triple bond is much shorter. All right. So okay, so this is a types of bonds and bond order. Right. So this is not that. This is very straightforward. Okay, this is very straightforward. The bond order, by definition, is number of electron pairs being shared by any pair of bonded atoms. That's by definition. Okay, for example, if we have hydrogen, H2, HF, or F2. Okay, that's a one sigma bond we got there. So a single bond has a bond order of 1. A double bond has bond order of 2, for example, oxygen or C2H4. A triple bond, for example, N2 and nitrogen, right? And triple bond N, right? So a triple bond for nitrogen has a bond order of 3. All right, so for polyatomic ions, okay, this species consists more than one atoms, usually covalently bonded, for example, between C and N here. Okay, carbon and nitrogen here. It stays together as a single charge unit. All right, so this is polyatomic ion. Okay, so C and N. Okay, you can see here, the charge is -1, and then it has a triple bond here. Okay, so in the atoms in the polyatomic ions held together by covalent bond. Triple bond is a covalent bond. Okay, and it forms crystal lattices. Okay, so let's move on to another subtopic of interest, which is the Lewis formula of molecules. Okay, Lewis formula of molecules can be used to show patterns of valence electron distribution in the molecules, which actually can allow us to predict the shapes of molecules. We will learn that later in this section of VSEPR, and then also can be used to predict the properties of molecules and how they will interact together. Okay, shapes and also the properties. Okay, these are the conditions that I assume every chemistry students already understand about the Lewis structure. The common bonding patterns. Okay, for carbon we have 4 bonds and 0 lone pairs. Okay, of course, C, and then we have 4, 1 2 3 4. Okay, 1 2 3 4, which is single. It can be 2 double or single plus triple or 2 single plus double. All right, so it contains 4 together. Carbon can have bond only 4 bonds surrounded the, because one bond represents 2 electrons. So to achieve of that needs 8 electrons together, right? So nitrogen 3 bonds and 1 lone pair. Oxygen 2 bonds and 2 lone pair. Hydrogen and halogen 1 bond. Beryllium 2 bonds and no lone pairs. Boron has 3 bonds and 0 lone pairs. Beryllium and boron actually are the elements that has a deficient electrons. So you have learned that in the periodic table section. All right, so now we move on to drawing Lewis structure. Okay, these are the steps to be taken when we draw a Lewis structure. Step 1, 2, 3, 4. Okay, bye. One is we have to count the total number of valence electron. The second one, write the skeletal structure. Doesn't matter. Okay, it doesn't matter as long as you draw the most symmetrical arrangement that you can do. Let's say CO2. So CO2 meaning that there are two oxygens, one carbon. So carbon and then not zero, oxygen on the left and oxygen on the right. It doesn't matter. It doesn't matter whether it's as long as it has a most symmetrical arrangement, and the central atoms must be the least electronegative. To know this, you have to know the periodic table. Okay, so the atoms or elements on the right side of periodic table is the most electronegative. Step 3, use two valence electrons to form each bond. Okay, step 4, complete the octets of the outer atoms by distributing the remaining valence electrons in pairs. Okay, you 2 2 2 2 until every atoms actually complete octet. Then you have to the remaining electrons on the central atoms. You have to put the remaining left electrons on the central atom. Is the central atom doesn't form an octet, it can form double or triple bonds. Okay, we have to look at later the example. Okay, so writing Lewis structure for covalent molecules. For this, okay, all right. So first, we have to attach atoms together in the skeletal structure. Okay, the metallic element, we have to put it at the center, and then the halogens or hydrogens are the terminals. Okay, a few reminder though. Okay, many molecules tends to be symmetrical. Okay, however, though there are some exception. Okay, so chemical formulas are often written to indicate the order of an atom attachment. For example, in C2Cl4, there are two Cl's on each C2 on each carbon. Okay, so actually the chemical formulas will help us to determine the how to draw this molecule. In oxy acid, okay, in oxy acid, for example, for sulfuric acid, the acid hydrogens are attached to an oxygen. Okay, for example, in sulfuric acid, the S is in the central. Okay, the O's are attached to the S, and each hydrogen is attached to a different oxygen. Alright, so these are the example of Lewis structure for PCl3 and C2Cl4. You can see that. Okay, so PCl3, all the electrons are enough. This is a stable compound. And then for C2Cl4, okay, the electrons are all occupied by the Cl4 Cl, and then making the double bond in between C and C. Okay, the next step, calculate the total number of valence electron available for bonding. Okay, what we can do is we need to use group number of periodic table to find the number of valence electron. For example, Na plus, so 1. Magnesium 2 plus, so 2 valence electron. Aluminium 3 plus, so 3 valence electron. Okay, all right. So now, for example, we have nitric acid. The first thing that we do is we draw the all the elements. Okay, hydrogen on outside attached to one of the O's, and then N is the centrals. Okay, so now we have to count the valence electron. For nitrogen we have 5, right? Oxygen we have 6. How many oxygen there? 3. So 3 times 6 is 18. Hydrogen, only one hydrogen, so 1. So 18 plus 1 plus 5, we have 24 electrons. Next, we have 24 electrons, so we can use actually 8. Why 8? Because we have 4 bonds between atoms. HO, 1 bond. ON one bond, ON there are 3 bonds. So 1, 2, 3, 4, 5, 6, 7, 8. 8 used, left is 16. So now we have to put another 16 here. All right. So we put 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16 is enough. So this is the bond is complete. Okay, nothing left, left 0. So keep going until atoms have n octet or you run out of electrons. Okay, in this case, it's enough. Okay, so if the central atom doesn't have an octet, for example, in this case, nitrogen, okay, nitrogen is not octet yet. Why? Because nitrogen has 3. So what we can do is we can bring in the electron pairs from outside atom to share. So in this case, we bring this kind of these two pairs of this one pair of electrons to this side. So now it becomes double bond here. Thank you so much, and I see you in the next video.